Hi folks, John Musgrove from SMC at North American Switchgear, and today we're popping breakers. I got a 225 amp breaker. We're going to do an instantaneous test at 2,250 amps. I'm going ahead and gauge, and we just had an alarm, meaning that one of three things have happened, preventing us from being able to hit the current that we desired. I call it IPI. It means we've got too much impedance, we don't have enough power, or inductance is affecting us. Now, we may know how much resistance our breaker has, or any other apparatus, but once you add your cables, once you add your clamps, your jigs, or anything else that enters the picture, we have a total amount of resistance. The Raptor has a way to overcome that. We have a built-in template and a way for you to do a complete resistance measurement of the entire path and overcome that. The second factor is power. Right now, I should be on 240 volt service. However, I look at my voltmeter built into the Raptor, and it's only showing 217 volts, which is also pulling down the current that I can achieve in this particular case. Third, and certainly not least, is the inductance. This is an induction-based system. Anything that we pass through this spire, we're putting current on. So it's very important to keep these cables closed, tight, in my case, twisted, so we can deliver the maximum amount of current. We put all of this into the best tool on board with the Raptor. It's called the current calculator. It allows you to put in your input power, the impedance, the number of cables, and it will tell you accurately in 3 seconds, 3 minutes, and permanent duty cycle what this system will achieve. Let me show that to you right now. Here we have the Raptor current calculator, which is also available on desktop for Windows at the link that you see below. This is made up of several different attributes, including the line voltage, how many number of Raptor masters that you have, which is currently only available to be one, the number of 5 kVA slaves, the type of cables that you have, whether it be in gauge size or millimeter square, number of cables, the length of cable, number of turns, impedance, which will give you how much current you can get out in 3 seconds, 3 minutes, and permanent duty cycle. This is the setup that I'd had to flip my breaker previously, but our line meter showed us that we only had 217 volts, which instead of me being able to get 2408 volts, I was only able to achieve 2156, which put us just below the threshold of the 2250 amps that I was trying to achieve. This is the portion that I was talking as far as the IPI of the power portion. The load impedance comes into play and will increase or decrease depending on how much impedance you have. The more impedance, the less current output you're going to have. The less impedance, obviously, the more. The bigger breakers are going to have less resistance built into it. Of course, that can be offset with higher line voltage, or you can compensate by adding additional cables, additional kVA slaves to increase that power, number of cables, and number of turns to double that power. What we're seeing here in 3 seconds, 3 minutes, and permanent duty cycle, when you see the red for any length of time, is going to increase the thermal or exceed the temperature on the cable itself. So this is a perfect tool to be able to manipulate and play with, even allowing you to decide on what needs to go out into the field before you load up that truck or van, telling you, do you need just the main Raptor system, or do you need to take 1, 2, or more 5 kVA slaves along with you?